Hi everyone, welcome to Simply AI, a place where I explain all the complex and treated AI concept in a simplified and easy to understand manner. Let's start this session, which is about machine learning. In previous session, I have given overview about what's machine learning, deep learning, and AI. So if you feel left out, you can always go and watch previous session. In this session, we are going to learn about supervised learning and other topics under it in detail. We already discussed few things in previous session, like what's regression and classification. We will do quick recap of that in this session, and then we will move on to our today's agenda. Let's revisit the supervised learning. In supervised learning, you will always have a hypothesis function. Sometimes we call it a prediction function as well, and it will take x as an input parameter and return y, which will be output. So, for example, to recognize cat in a picture, so where X is an image and Y contains whether cat is there in picture or not. Or to identify the hate speech, where you have some random text and Y equals to 1 will represent, okay, it's hate speech, and Y equals to 0 will represent it's not hate speech. To predict the house pricing data, where you can pass the few parameters like the size of your house, number of rooms, number of bathrooms, and it will predict the price of your house. Similarly, there can be other examples like image and speech recognition, recommendation systems, and fraud detections, identifying whether the mail is spam or not spam. These are all example of supervised learning. Okay, so one very important term which you will hear is training set. So here xi and yi will represent the ith training set. So whenever I will say x2 or y2, it means these are the second example in my training set. There will be n number of examples, right? So x will represents the input and y will represents the corresponding output. So now our task is to create hypothesis. Now how to create hypothesis, we will discuss that later. But you need to know that hypothesis is a function which will take the input from the user and it will predict the output. That's why like we will want to use H means hypothesis on the new data, not in the training data. We will use training data to get our hypothesis, but we will use that hypothesis for new data. Okay, so as we discussed earlier, if y is continuous, then it will be a regression problem. And if it is a discrete, then it will be a classification problem. For example, image is cat's image or dog is a supervised classification problem. And the predicting house price is a regression problem because here the y is the continuous. If y is a discrete where you are classifying something like these images are cat's images, these images are dog's images, then that is the classification problems. And both regression and classification comes under this supervised learning. So today we are going to cover the regression and not we are not going to cover the complete regression. We will just talk about the linear regression where we will take our hypothesis as a linear function. Okay, so our first example is going to be a housing data. And here we have a square feet size of the house as an input and price of the house as output. And we can map this data in graph like this. So for this input output, what will be our hypothesis? For now, we are taking a line. Okay, so we all know the equation of the line is y equals to mx plus c, right? Where m is a slope and c is a constant. So when you pass the zero, the mx will be a zero and c constant will be value. So you can say c is the value of h of 0, like when you are passing x equals to 0. So that's the hypothesis because we just want to take the linear hypothesis. We can write it in a slight different way. Here, theta 0 and theta 1 are parameters. So in our case, the m and c was the parameter. Here, theta 0 and theta 1 are the parameter. And x0 and x1 are input. So we are considering like x0 is equal to 1 and x1 will be your house size. So your equation will be theta 0 plus theta 1x, which will be like mx plus c. So here, if you will compare, the m will be theta 1 and c will be theta 0, which is the constant. Okay, so in our input and output pattern, you can say the x1 is the square feet size of the house, and the h of x will be the output, and that output is the price of the house. Okay, so as we can see here, theta 0 and theta 1 are very important, and prediction is defined by theta 0 and theta 1. Okay, it's the similar example, like here x1 is at 104, which is the size of the house, and the y1 is the corresponding price, and similarly x2 represents the second training data, and we can have n number of training data like this. So let's draw our hypothesis also. Okay, so let's draw our hypothesis, which is this. Okay, so this black one is the initial random line. So initial time, we are going to take theta as some random value, so you will get some random line, right? And that is initial random line. Your goal is to get that final trained line. Now, how will we do that? We are going to discuss that later. But that is what our goal is. We will take some initial random line, and then we will tune it, and then we will get our final trained line. Okay, so let's take slight more interesting data. So if we have multiple feature, suppose the number of bedrooms, number of lot size, then our prediction or our hypothesis function will be like this: theta 0 plus theta 1 x1, theta 2 x2, and theta 3 x3. Here x1, x2, x3 are the three features, which is size, bedroom, and lot size. And for each features, there is one parameter. So this is the linear representation of hypothesis in case if you have a multiple feature. Okay, so for now you just know, like, this is how we represent it. After you know after doing few computations, we are going to implement this in Python also. So at that time we will have more clarity. We can write this hypothesis in a different way, like this. So we can take the help of sigma, and we can write same equation like this. So basically these two equations are same. So sigma represents, like, it is starting from the 0 and going up to 3. So theta 0 x0 plus theta 1 x1 plus theta 2 x2, and so on. And here x0 will be 1. So theta 0 x0 will be theta 1 theta 0, and that will be our constant. Okay, so what do we want to do next? So I think it's very clear, right? We want to get the trained hypothesis, right? Because we have some random hypothesis till now. So we can say that we want to choose theta so that h of x will be likely to y or similar to y. You can read this symbol as likely to y or similar to y. So our task is to choosing theta. So one idea is called least square. So least square is this. So it's just like whatever the our hypothesis will return, we'll do the minus of output, and then we are squaring it, and we will do this for every training example or for every training set. So that is our least square, and we can call this as a j of theta, which is our loss function. We call this as a loss function or cost function also. Okay, and we can call this squared loss also. So you would have heard like squared loss, so that is what it means wherever you will hear that squared loss. Why square? That we will discuss in some other session. Why don't we just take the h of theta x minus y? Why are we squaring this? And why are we not taking cube or some other things, like y is square? So we're going to discuss that later. But for now, just keep this thing in mind, that you're calculating the squared loss of your hypothesis. So this is going to this. So now what your goal is to the minimize the j theta. Okay, so now our goal is to find theta such that value of loss j theta should be minimum, or find, we can call this as argument minimum, because our goal is to find theta or parameter in this case. So the I'm hoping that you guys are aware about argument minimum. Argument minimum is nothing. Uh, it's you can just say that find an argument for which your function has minimum value. So suppose if your function is x minus 2 square, so your argument minimum will be 2, because when you pass 2, the the value of this function is going to be 0, which is the minimum value. So what is the argument for which your function has minimum value? So similarly here, j theta is our function, and what should be a theta for which j theta will have a minimum value? That is what our task is. Okay, so before moving forward, let's see what did we learn so far. So we saw our first hypothesis of uh, function, which is the linear function or affine function, and then we refresh ourselves on notation and introduce like parameters and features. So theta we discuss are parameters, features, like there can be a number of features like number of bedrooms, number of bathrooms and all. And then we saw our loss function, which is squared loss in our case. Now we'll see how to solve these equations. So our new task is to find argument minimum for our loss function. One way to solve that is using gradient descent. So here I'm just going to give you the overview of the gradient descent. I will give you some gradient descent video link in description, so you guys can go and check that out. For now, let's just get an overview of it. So this is the gradient descent formula, and theta j is the initial random parameter. So initially you take some random parameter, and that theta j is initial random parameter. Now you want to minimize the j of theta, right? So you know that the definition of derivative is what? Derivative of any function represents the change in output with respect to the input. So you're going to change your input very slightly, and you're going to find out the change in j theta. And then alpha represents step size here. So suppose you know that this is the change. Now, now how fast do you want to update your parameter, right? It depends on alpha. If your alpha is big, that means you're very you're taking a big step. If your alpha is small, that means you're taking very small step. If you're not getting this, you do not need to worry about this. Once we will implement this in Python, I think then it will be more clear. So our final formula in words we can write like our final parameter is going to initial parameter minus step size into change in loss with respect to initial parameter. So that is what our final formula is, or what we are doing as part of gradient descent. Okay, so let's compute the derivative. So this is our j of theta, h of x minus y. So this is our j of theta, and this is our squared function, correct? Our squared loss. And if we will take the derivative of our squared loss, so the next thing, this is going to be our next step, where we will calculate the derivative of our hypothesis function. So we know that the derivative of xn equals to nx to the power n minus 1. So from this formula we got this, and now we want to differentiate, we want to do the derivative operation on our hypothesis function. We know our hypothesis function is the theta 0, x0, theta 1, x1. So if you are doing the derivation with respect to theta j, and we know since our hypothesis is theta j xj, so xj will be our output, right? Because everything else is going to be 0, because everything else is going to be constant. Only theta j, or suppose if theta j values is 1, then x1 will be answer. Other terms is going to be 0. So the final derivative is going to be xj. Now what is the j? J is the number of parameters. So as we discussed, right, if there are 3 features, there will be each parameter for each features and one constant. So if there are 3 features, there will be 4 parameters, correct? So the xj will go from 0 to 3. So total there will be 4 parameters. Now this is our final, you know, the formula where the final theta is going to be initial theta minus alpha, which is the learning rate, and then derivative what we have calculated here. After a few slides, I'm going to implement this in Python, and I think if it is not making sense here, it will make sense when I will try to implement this. So I think we are almost done. Okay. Our task was defining theta, and now we have a gradient descent algorithm from where we can get the new theta. Now, new theta is not our final theta. We are going to iterate that, and from each iteration, our theta is going to be tuned, and we will tune that unless and until we get our desired loss. What I'm talking about, actually, I think we'll implement this in coding. So, just quick recap of complete um, theoretical system here is we have a training set x I y I till x and y n, and then we have a hypothesis. Hypothesis is theta 0 x0 theta 1 x1, and here x0 x1 are the parameters, right? The number, sorry, features. So that is our hypothesis, and then we have a loss or cost function j of theta, which is squared loss this time, and we want to minimize our squared loss, and we want to find the argument, or we want to find the parameter for which our loss is minimum, and that parameter we are going to find using gradient descent. So when we implemented gradient descent, we got this final output that our final theta is going to be initial theta minus alpha into our loss, and then x of j. So we can say this term is directly proportional to our cost function or loss function. So whatever the loss or cost is going to be, we can directly put. So we do not need to calculate this separately. So let's try to implement this thing, or let's try to implement whatever we have learned so far in Python. Okay, the one thing which I must say, in Python, I'm going to use few libraries like Numpy and Matplot for plotting. So I'm hoping that you guys have the basic knowledge about the Python, Numpy, and Matplot. If you do not have any idea about Python, Numpy, and Matplot, I'm going to uh, give few tutorials or videos in description. You can go there and you can learn the basics. And after some time, I think after 1 or 2 sessions, I'm going to create the videos in all those the add-on topics, so that you guys can have a better understanding. So let's move to coding implementation. I'm using the Visual Studio to code the linear regression problem, and our Python version is Python 3.10. So you guys can check your Python version, and this is the content environment. So basically, I have installed a Jupyter notebook in my PC, and now I can run the notebook on it. So before starting, this is the file name linear regression one feature.ipynb. Why one feature? Because right now we are just going to write the program for one feature, and probably in the next session we are going to write the program for the multiple features and few other scenarios. So the first thing is importing few libraries. So I'm going to import NumPy, so NumPy as np, and then so basically NumPy we are going to use for the array operations. So we will have the set of operation which is required as part of our algorithms, and we are going to use the NumPy for that. Now we will be using the Matplot Lib, which is the libraries for the plotting. So basically, just make the the data visualization easier. So we are going to use this as PLT. The one very important thing, which is the random, and that is inside the NumPy package. So just so that we don't need to write again and again NumPy.random. We will just import the random from NumPy. From NumPy import random. Okay, we just executed this. Uh, as we have discussed, right? We are going to take some random theta initially. So this random is going to do that part. I have already taken the data. So this is the input size and this is the output price. So you can consider these are the the size of your flat, and these are the uh, the price of your flat or property. Now we can just the print the shape of these um, input size dot shape on these array actually. Okay, if you will run this, it's going to return 15 comma. So that means this is just a one row vector, or you can simply say this is the array. And uh, so as we have discussed, right, this is our training set, and training set will have xi, yi. So it should be, the size should be, or the shape should be the same. And here the xi, yi, x1, y1, and x2, y2 are the corresponding value. So now we have input data. Another thing, the another part was considering our theta 0 and theta 1. So we have theta 0. It is just a random variable, so we are going to use the random dot ran n. So it will just generate the, if you go here, you can see what this function does. So return a sample from the standard normal distribution. So this will return the value from the normal distribution, and will return the, the random value. So we are just going to generate the one random, value, which is going to be theta 0. Similarly, we are going to generate the other random value for the theta 1. So these are just, the random value. If you want, we can just print this value. So theta 0 is going to be theta 0, and similarly, we can write for the theta 1. So these are the theta 0 and theta 1. These are just a random value. Now, if we want to, the print our hypothesis. So right now we are not doing anything. We just, want to print like how will uh, our hypothesis will look like. So we can say it will look like theta 0, which is their constant, plus theta 1, we can say, into x. So, right? So this is the uh, hypothesis. So theta 0 into x0, and x0 is a 1, plus theta 1 into x1. So here we have just named it as x. So this is our initial hypothesis. Let's try to visualize this data. So uh, what we can do, we can just use plt.plot to plot these values. So suppose after tries and input sign, and then plt.sign. So we'll do this. Okay, so we don't want to plot these lines type of structure. We just want to just want to, plot the points. So we'll just pass the specific O, so that it will just plot the dot. So this is our data, right? And for this data, we just want to uh, plot our hypothesis also. So this is, we have initial theta 0 and initial theta 1. So how will we plot our hypothesis? So we know our maximum value is somewhere like 23, 25. So we'll take one variable x, which is going to the np dot line space. So what line space do? It if you want to, uh, so if you want to, map your line or something evenly, you can use the line space to generate the value from start to stop. So right now we are going to do for 0 to 25. Okay, so this is going to our x, and now we are going to plot our x. What is going to our y? Our y is going to x into theta 1 plus theta 0, and we'll just add the line style, which will be a solid. Let's execute this. Okay, so we don't want this. So first we'll plot everything, and then we will so we'll move field also at the end. So now let's see. Okay, so this is our initial hypothesis, right? This is the some random line. Now we can visualize our data, and we can say that okay, we want to make this line, or we want to train this line, so that we get a best fit line. Uh, Before that, I'm just going to write one function, which is the loss function, or which is squared loss, right? So as you can say that we now we have our input, we have our output, we have our initial parameters, and we have plotted our input output, and we have plotted our initial hypothesis also. So let's check what is the initial loss. So I'm just naming as a m and c, where the line equation is going to mx plus c. So your loss will be just, so whatever input is going to be to m, so which is the mx, and then plus we will do c, close the bracket, minus, because our hypothesis was, so this was your hypothesis, right? So mx plus c is our hypothesis. Now we want to do the minus y. So we'll do the minus output, and we'll close the one bracket again here. So this is the output one, and the star star. So in Python, when you do the star star 2, that means it's a square. So we have done this part. Why sum? Because we want to sum each value from 1 to n, right? So this sum is going to sum up all these. Now by 2. So that is a, in one bracket we are missing. Okay, so that is our loss, and we are just going to return loss. Now just calculate what will be, so pass what will be our initial loss, pass the input size, pass the output price, pass the theta 1, and pass the theta 0. So m is theta 1 and c is theta 0. So 4080 is our initial loss. Now our next important code is gradient descent. So let's implement a gradient descent. I'm just going to create the one function name as a gradient descent, so that whenever we want to use, we can use that. So we will take input, we'll take output. We are going to take theta 1, we are going to take theta 0. So we have an input, we have an output, and then theta 0 and theta 1. Now our task is, so let's check out first what is the gradient descent. So theta, there are two theta, right? So we need to do the operation for both the theta. Let's discuss about first this term. So this term we have already written, right? Where hypothesis minus y into xj is something extra, and then we need to sum from 1 to n. So here what we are going to do, we are just going to use the loop to sum these values, and then we will multiply that, whatever that output is going to be, we'll multiply by alpha, which is learning rate, and then we will do the minus whatever initial data will be. So you can just say that, you can just name this as a sum of theta 1, because here there will be multiple theta, right? So for there will be one, we can say is sum of theta 1 and sum of theta 0. So that sum of theta 1 or theta 0 is going to represent this value. So let's do that. So I have created one value, sum of theta 1, which is a 0, and sum of theta 0, which is also 0. Now for I in range of just length of input. So if we have given the 15, because our input size is 15, right? So we have given the 15 training value or the training examples. So we are just going to iterate 15 times, right? We want to multiply the theta each time. So now for I in range, sum of theta 0 is going to be sum of theta 0 plus hypothesis minus y, right? So this is hypothesis minus y into x of 0, which is the 1. Similarly, we can just write, let me just write the other line also, and then we will do the same thing for both lines. So sum of theta 1 is going to be sum of theta 1 plus, now our hypothesis, which will be theta 1 into input of I. Why input of I? Because our x is input of I, right? So when I is 0, we are going to talk about the only first training set, and then second training set, and then third training set. Like that, we are going to do for every training set. So theta 1 into input I, that is our mx, and mx plus theta 0, which is the c. Now this is our hypothesis function. We want to do the output of I. So ith input and output. So this is our total in the complete hypothesis function. We can replace same thing here also. Now, in case of theta 0, the x0 is 1, so into 1 it is not, it is going to be same. But in case of theta 1, we want to multiply it by x1, right? So theta 0, x0, theta 1, x1. So x0 was the 1, but in case of the x1, we need to multiply by x1. So the input of I, this is our x1, and then closing bracket. So this is our sum of theta 0 and sum of theta 1. Now, let's apply our main rule. So this for loop is only to calculate this sigma value. Okay, so now let's write our main gradient descent formula, which is like your final theta equals to initial theta minus alpha, whatever the sigma value is going to be. And there are two theta, so there will be two line code. So theta 0 is going to be whatever theta 0 is minus alpha. Okay, alpha is not decided yet. So just write that alpha theta 1 variable is equals to 0.001. Why we are taking so small alpha, I'm going to tell you after running this program. So alpha into the sum of theta 0. So sum of theta 0 is the sigma value of this equation for the theta 0. And when we are going to do the same thing for the the theta 1. So this is the theta 1. Okay. So now we have a updated theta 0 and theta 1. So this is the first step of your gradient descent. But if you're going to do the first step, you're not going to get your the best fit line. You need to do this again and again until you get your best fit line. So how many times? We don't know. We will just take some random value and we will see. So just let me, add one line of code where I'm going to I in range. Suppose I'm doing this 30. Okay, I'm just going to run that 30 times. This is going to be inside that. I'm going to run everything like 30 times. And my alpha is 0. At the end, I'm just going to return theta 1, comma, theta 0. So this is the value which I'm going to return after running 30 times my iterations. Okay, so just we can say new theta 1, comma new theta 0 is equals to gradient descent input size output size theta 1 theta 0. This is going to be new theta 1 new theta 0. Okay, so we'll just print the I think here also. So we'll just copy this code, paste it here, just add new everywhere. So new hyphen, so new theta 0, new theta 1. So this is our hypothesis, right? This is our new hypothesis. Okay, do we want to plot also? Do we want to plot the new hypothesis? Okay, so we have the same code where we will plot our input size, output size, line space, x instead of the theta 1. We'll just take our new theta 1 and then new theta 0. Okay, so what we are doing, we're just getting the new theta using the gradient descent. Then here we are printing the values on the theta, and then this is our new hypothesis. And with respect to this input size and output size, we are plotting everything in um, one graph so that we can see how it is working. So we have run this thing till here. Just run this thing and see what's the matter. Oh, well. So as you can see here, right? You can see the line are kind of trained. We don't know whether it's trained or not, but it looks strange. So our initial line was like this. Now our final line like this. Let's make few code changes so that we can visualize it a little more. And let's check our loss function also. So each iteration when you are doing, what I just want to do, I just want to print a loss iteration. So I'm printing the I. It will say like this is the ith iteration and loss is going to a loss function, and loss function is going to take the input size, price, comma, this thing, right? Theta 1 and theta 0. So here we are just printing the loss. Other than the printing the loss, let's move this line here. So before calling the gradient descent, you just plot the data, and here we are just going to draw our line. So just okay, so I think you got this program right. So these three lines are just for the printing few things, like the print um, what is the loss value, and then the I just want to print the line. Each iteration I just want to see where the line is moving, and then I just want to calculate the new theta 1, theta 0, and then again I will go here, I will print my loss, and again I will print my line, and at the end I just want to show everything, and this is going to be our final line. So it's like I want to print the I just want to print out my final line here. Okay, so let's run it again from the start. So this is the value where we have our input value. This is our hypothesis, or the random values. Now this is where we plot. So see, this time our line is the more random, and you'll see it's too far from our data set, right? So if you will see the earliest, since the line was closer to our points, the loss was 4080. Now this time the loss is going to more than 4080. So okay, see, this time the loss is something 7000 because the line is far from our the points. So now let's run this program where we are optimizing the line, and let's see how does it work. Okay, so if you will see, our initial loss was 7000 something, and after each iteration you can see the loss is getting decreased, right? It's 5000 and then 3000 and then like this, and our final loss is some 7064. And we will see this was our initial line, and each iteration this line is moving closer to our points. So this is how gradient descent works. So this is getting close to close to our point, and our final line is this, which I mean you cannot see here. It's kind of all the lines are mixed up, but now since this is our final line, we will use our final line to predict some value. So you can say this new theta and new theta 1 is our final theta, and we will use these two, theta 0 and theta 1 to predict something. So let's, in this line, just write the one function uh, where you will say the predict price, and you just pass in the size, and you'll see the return, and I'm just going to take this value. It's the same thing. So new theta only 1, and then extra size. Print price for, we have this data. Suppose we just want to get value for the um, these are the square fish size, right? So we just want to give the value for the 8 square fish. So I mean, I have just taken the random value. 8 size will be predict price and pass 8. So 15 is going to be the prediction or predicted price which we will pass it. So this is how we will use our hypothesis to predict the value. So I think by this example, the concept is clear, right? We have the training set. We use training set to create our hypothesis, and then here is our squared loss function. We want to minimize this loss, and in order to minimize this loss, we use the gradient descent algorithm. And each iterations of gradient descent algorithm minimize losses a bit, and we'll just do the multiple iterations. So this step is called the training the model. So you would have heard of, right, like we are training the machine learning model. So this is what it is. So right now the data is very less. It is just the 15. When we'll take the very big data where there will be the millions of rows, and there will be n numbers of features, then this step is going to take a lot of time. So it's like 1 hour or 2 hour you are just training your model. So again, there is one step which is this one. This is kind of is competition heavy, because each time you are just iterating through uh, the total number of input, and you're doing this again and again, right? If you want to do it for, you're doing this for theta 1 and then theta 0, and suppose if you have multiple features, you're going to do this multiple time. So this algorithm which is implemented here is called the batch gradient descent. There is more better way of doing it, and we call it as stochastic gradient descent, and we are going to implement that in our next session. Okay, so today we learned the linear regression for one feature. In next session, we are going to learn the linear regression for multiple features, and how can we take the help of vector um, and algebra in order to solve that issue. And after that, we are going to implement that whatever we are going to learn. So basically, we are going to implement the linear regression for multiple features um, using a normal approach and using a vector approach as well. So yeah, that is about the next session. Questions. So if you guys have any question or queries about the technicalities or about any coding, you guys can comment it down. Few things which are in prerequisites, like you should have the basic knowledge about the Numpy and Python and the basic mathematics. So I will just put a few links or video links in description box. So yeah, you guys can always post whatever queries you have in comment section. So that is it for now. We'll meet soon. So please like and subscribe to my channel and click the bell icon to get new video update, which is going to be very soon, probably the next week. Okay. So thank you very much.